Have you ever wondered how a massive Douglas fir log can be transformed into paper-thin sheets of wood in just a matter of seconds? Behind this incredible process lies a combination of giant steel blades, high-speed veneer peeling systems, and some of the most advanced manufacturing lines in the United States. In today's episode, RaWMachines takes you inside the fascinating world of structural plywood manufacturing. Let's uncover how it's all done. Mornings in the Pacific Northwest always begin with a distinct, profound stillness. Towering dozens of meters into the sky, massive Douglas firs stand seamlessly interwoven with the endless green of the ancient forest. Some of these timber giants have stood here for generations, anchoring the memories of snow-blanketed winters, relentless rains, the breath of the earth, and the indelible marks of time. Yet, the day inevitably comes when these trees must embark on an entirely new chapter. Shifting away from the classic image of loggers wielding traditional chainsaws, the vast majority of today's heavy lifting is driven by advanced forestry harvesters. A high-powered hydraulic felling head slowly reaches out, locking into a crushing grip around the base of the trunk. Then, a high-speed circular saw blade spins up, slicing through the massive stem with absolute definitive authority. The instant the tree falls, the processing head immediately goes to work, stripping away branches, topping the crown, and bucking the trunk into standardized log lengths tailored for specific production lines. In just a matter of minutes, a Douglas fir standing nearly 40 meters tall is fully prepped and primed for its journey out of the woods. Then comes the critical phase of transport. Heavy-duty hydraulic loaders gently hoist logs weighing several tons onto the log trucks. Arranging the payload is far from a simple packing job. It is a complex puzzle of center-of-gravity mathematics and structural balance. The driver must execute a rigorous safety checklist, from cranking down heavy-duty tension straps and monitoring tire pressures to thoroughly testing the air brakes and safety stakes. They know all too well that on these treacherous logging roads, complacency simply cannot exist. The loaded rig begins to roll out, crawling at a cautious 15 to 20 kilometers per hour. The road ahead snakes relentlessly through the rugged mountainous terrain, where steep grades, slick, unpaved surfaces, and blind hairpin turns demand absolute, unwavering focus from the man behind the wheel. After hours of grueling travel, the landscape finally begins to shift. the ancient forests slowly recede into the distance, giving way to sprawling log yards, heavy steel perimeters, and massive industrial facilities with network piping continuously venting plumes of white steam. This is the exact arena where the raw timber will be reborn into an entirely new form. Looming ahead of us is the Arauco facility, one of the most advanced wood processing plants in the United States. Every single day, thousands of logs sourced from sustainably managed forests converge on this very site. Yet, before they can ever be transformed into micro-thin veneers or engineered plywood panels, they must first pass through a highly meticulous deep prep phase. Out in the log yard, a massive industrial sprinkler system runs continuously, blanketing the entire timber inventory in a heavy rolling mist. This isn't about washing away dirt. It is a calculated measure to keep the bark and inner wood fiber locked at a perfectly stable, uniform moisture level. The most critical stage takes place in the conditioning tank. Here, the logs are continuously soaked in hot water at 85 degrees Celsius for 18 hours. This meticulous preparation ensures that during the peeling process, the veneer sheets glide off as smoothly as a ribbon of silk, without tearing the grain or splintering. Once the logs are ready, they move on to the veneer lathe. Each log is firmly secured between two rotating spindles. As it begins to spin, a massive steel blade is slowly pressed against its surface, peeling away a continuous ribbon of thin wood veneer, much like peeling the skin from an apple. The difference is that this apple weighs several tons. An industrial vision system then scans every sheet of veneer. Computers inspect each panel for defects, such as knots, splits, and surface depressions with remarkable precision. Sheets that meet quality standards are automatically sorted by moisture content, size, and color. Those with imperfections are flagged and diverted for separate processing. Next, the veneer sheets are dried in a multi-stage hot air drying system at a temperature of approximately 180 degrees Celsius. The purpose of this process is to reduce the wood's moisture content to approximately 6 to 8%, which is the optimal level for the pressing process. After drying, the veneer is conditioned in a moisture-balancing storage area for 24 hours before assembly. Although this is a relatively short step, it plays a critical role in ensuring the stability of the wood fibers. In many facilities, broken or undersized veneer pieces are discarded. At Arauco, however, they are repurposed to create new veneer sheets. Automated robots collect the pieces and join them together using finger joint technology through the composing process. This increases the bonding area while maintaining the strength and integrity of the veneer. For face veneers with minor defects, the patching process removes the flawed sections and replaces them with sound wood patches. Operators perform a final inspection to ensure consistent color and grain matching throughout the veneer. After processing, the veneer sheets move to the gluing and pressing line. Arauco uses two primary adhesive application systems, a roller coater for liquid adhesives and an automated extrusion glue system for thicker adhesive layers. The adhesive is applied evenly across each veneer surface before the sheets are stacked together, with every layer rotated 90 degrees from the one beneath it. This cross-grain construction counteracts wood's natural tendency to shrink and expand, minimizing warping and cracking, while dramatically increasing the panel's strength in multiple directions. After the adhesive is applied, the veneers are transferred to a cold press, allowing the glue to penetrate evenly. They are then moved to a hot press at approximately 130 to 150 degrees Celsius under pressure exceeding 200 pounds per square inch. In just a few minutes, those separate layers of wood are transformed into a finished sheet of plywood, strong, flat, and seamlessly bonded into a single solid panel. At the final stage of the production line, a sensor system scans the entire surface of each panel to detect even the smallest defects before the products leave the factory. All collected data is checked against international technical standards. Products that do not meet the requirements are marked for repair using water-based filler or polyurethane. If they still fail to meet quality standards, they are sent to a manual repair station. Next, the edge trimming machine finishes each panel to precise dimensions, while the sanding machine brings the surface to the required smoothness standard. Each panel is then graded by strength, color, and flatness. Depending on its intended use, some panels may be grooved for decorative purposes or pre-finished with a protective coating. Finally, all products are bundled, labeled with the Arauco brand, and loaded onto trucks for distribution to construction sites and manufacturing plants across North America. Leaving Arauco behind, our journey takes us to the city of Cottage Grove, home to a major processing facility operated by Rayonier Inc. Every day, thousands of pine and Douglas fir logs flow into this yard to undergo a manufacturing process driven by near absolute precision. Only logs that meet strict size and quality standards are selected. Most are about 8 feet long, with straight, uniform grain and minimal defects to ensure they can be peeled efficiently. Before entering the production line, every log is completely debarked and thoroughly washed to remove dirt, sand, and other surface contaminants. While this step may seem simple, it protects the veneer lathe's cutting blade and helps produce cleaner, higher quality veneer sheets. At the heart of Rayonier's operation is the veneer lathe. As each log rotates, the machine peels away thin layers of wood into one continuous ribbon of veneer, each sheet only a few millimeters thick. Throughout the process, operators continuously monitor the cut and make precise adjustments whenever needed, ensuring every veneer sheet remains smooth, uniform, and free from grain tear. The continuous ribbon of veneer then passes through a clipper, where it is cut into standard size sheets. At the same time, an automated camera system scans every section, identifying and removing areas with rotten knots, cracks, or other major defects. The finest veneer sheets with consistent color and a clean appearance are reserved for the outer faces of the plywood. Sheets with only minor imperfections are still put to good use as the structural core layers. This grading process maximizes the value of every sheet of wood while ensuring the finished plywood meets the highest quality standards. At Rayonier, the drying stage is a battle of numbers. Freshly peeled veneer enters a multi-deck dryer where the flow of hot air is precisely controlled down to each degree Celsius. The goal is to reduce the moisture content to 8%. If the veneer is dried too quickly, it can crack or split. If it's dried too slowly, the entire production line loses efficiency. Once the veneer reaches the required moisture level, the dried bundles are tightly secured with steel straps and stored in a warehouse to keep them dry. These veneers then become premium raw material for flooring underlayment or structural sheathing panels. Perhaps the clearest proof of Rayonier's quality can be seen in the modern homes rising just outside the mill. Instead of relying on conventional engineered wood panels, local contractors consistently choose sheathing made from Rayonier veneer because they understand it represents a commitment to homes built to last for decades to come. Goodbye, Oregon. Our journey now takes us to Louisiana, where RoyOMartin has emerged as one of the wood products industry's leading manufacturers, representing the cutting edge of American manufacturing. Since its establishment in 1996, the company has continuously expanded its operations, reaching major milestones in 2006 and 2014. Today, RoyOMartin operates the largest and one of the safest plywood mills in North America, producing more than 500 million square feet of plywood and 35 million board feet of lumber each year. Behind this achievement is a team of more than 700 engineers, technicians, and production workers who keep the manufacturing lines running around the clock, 24 hours a day. The first stage is log processing, OLP, where every log is carefully optimized to maximize its value while minimizing material waste. Originally, the OLP line was engineered to process logs up to 26 feet long and 30 inches in diameter, producing a high yield of premium-grade face veneer. In 2006, RoyOMartin expanded its capabilities with a second OLP line equipped with a Letourneau JC40 crane-fed handling system. This advanced line can receive and sort logs measuring up to 62 feet in length, supplying raw material simultaneously to both the plywood mill and the sawmill. Further expansions in 2006 and 2014 significantly enhanced the company's ability to process a wider range of log sizes. These investments improved resource utilization, increased operational flexibility, and optimized overall production efficiency. Everything begins as the rough outer bark is completely removed, revealing the natural wood beneath. At RoyOMartin, this bark is chipped and repurposed into valuable biomass fuel, providing a sustainable energy source to power the mill's own thermal systems. The logs then pass through a laser scanning system, an electronic set of eyes capable of measuring every log with millimeter precision. In a matter of seconds, powerful computers analyze the data and make a critical decision. Ply blocks. The highest quality logs are directed to hot water soaking vats, where they are conditioned for the veneer peeling process. Saw logs. Logs with characteristics better suited for structural lumber are routed to the sawmill, where they will be cut into high-strength beams for construction. Logs designated as saw logs are fed through an automated canter, where they are precisely shaped into standard square cants measuring 4 by 4, 5 by 5, or 6 by 6 inches. The cutting system is optimized to maximize the recovery of high-value wood while minimizing waste. The cants are then bundled and loaded into industrial dry kilns. For larger dimensions, such as 6 by 6 inch timbers, the drying process can take up to 96 hours, reducing the moisture content to below the industry standard of 19% to help prevent warping and cracking. Once the target moisture level is reached, the lumber moves to the planing mill, where precision steel cutters size each piece to exact dimensions, while creating a smooth, finished surface. Finally, every piece is stamped with a TPI grade mark, a symbol of North American quality, before being loaded onto trucks and rail cars for distribution to markets around the world. Now, let's return to the plywood production process, the beating heart of the RoyOMartin mill. Here, raw muscle has given way to engineering precision. From the central control room, a single technician oversees the entire operation, managing everything from the saws and soaking vats to the wood chipper through a wall of monitoring screens. Every stage flows seamlessly in perfect synchronization, with the entire process running almost entirely without direct human intervention. After leaving the soaking vats, the ply blocks are fed into 2 veneer lathes. A laser system scans the surface of each block, identifying the optimal cutting path before the blade presses in. Each block is peeled into 4 veneer sheets of varying thicknesses, maximizing the natural structure of the wood grain. Once only the core remains and can no longer be peeled, it is transferred to the chip and saw system, where it is processed into landscaping material or decorative trim. At this stage, the veneer sheets still contain a high level of moisture. Known as green veneer, they are fed through a clipper, where the leading and trailing ends, areas most likely to contain defects, are trimmed into narrower panels with a minimum width of approximately 8 inches. This process maximizes lumber recovery while minimizing waste. Once cut into individual sheets, the veneer is transported by an overhead conveyor system and stacked into bundles for storage. Drying the green veneer is the next critical step in the production of structural plywood. To maximize capacity, 3 separate batches of veneer are spread out and fed simultaneously across the full width of the dryer. Heat inside the dryer is transferred efficiently through an advanced hot oil circulation system. Inside, 3 drying zones are carefully maintained at temperatures ranging from 380 degrees Fahrenheit to 420 degrees Fahrenheit. Each sheet takes 6 to 8 minutes to complete this transformative journey before exiting the dryer at a stabilized temperature of about 130 degrees Fahrenheit. As the veneer exits the dryer, each sheet is automatically scanned to determine its moisture content and assess its quality. The product is sorted from the highest N grade to X grade for inner layers, while also being classified into 4 moisture levels. Sheets that do not meet the required standard are returned to the dryer for additional drying. Once enough sheets have been collected for each grade, the veneer stacks are labeled with the date, moisture level, grade, dryer source, and then stored until they are ready for assembly. RoyOMartin operates 2 advanced panel layup lines. The spray line uses a high-pressure adhesive spray system for 5-ply panels, while the foam line utilizes precisely metered foamed adhesive to manufacture 3-ply panels. Next, the veneer sheets are stacked using a cross-grain construction, with the grain of each layer oriented at a 90-degree angle to the adjacent layer. This configuration evenly distributes loads, enhances structural strength, and minimizes warping and shrinkage. After the layup process, the flying cutoff saw automatically trims the veneer assembly into standard size billets before they are transferred to the cold press, where their shape is stabilized. Finally, the veneer stacks are fed into a hot press operating at pressures exceeding 200 pounds per square inch. Under carefully controlled heat and pressure, the adhesive fully cures, permanently bonding the wood layers into high-strength structural plywood panels that meet the most demanding standards of the North American construction industry. If the massive presses embody the raw muscle of modern engineering, then the power system is the silent heart that keeps the entire mill alive. At RoyOMartin, rather than relying entirely on the electrical grid, 3 enormous thermal heaters are fueled by biomass, using bark and wood chips to heat circulating thermal oil to an astonishing 271 degrees Celsius. Once the heat has been transferred throughout the production process, the oil returns to the heaters to be reheated, repeating the cycle. Without this system, the production line simply could not operate. After leaving the press, the untrimmed panels are transferred directly to the quality assurance area. Here, RoyOMartin conducts a rigorous quality control process, with samples collected multiple times throughout the day to evaluate adhesive bond strength and structural performance. This ensures that every panel meets all technical specifications before leaving the mill. Next, the panels pass through a skinner saw, where both edges are trimmed to standard dimensions. At the same time, automated ultrasonic and thickness sensing systems inspect each panel, detecting any deviations from the design specifications. Panels intended for structural construction are stamped with APA certification, stacked, strapped, and transferred to the finished goods warehouse. Premium products continue through a defect repair process using polyurethane filler, followed by sanding on a Kimwood sander to create a smooth, even surface before final inspection, grading, and quality stamping. The end result is premium quality plywood panels with smooth, attractive surfaces, consistent dimensions, and precise specifications, ready for packaging and shipment to customers. Uncompromising quality, unwavering commitment is more than just a slogan. It is the core value RoyOMartin has upheld for the past 28 years. Every panel that leaves the mill represents the standard of quality that the construction industry has come to trust and expect. The final stop on the journey was Columbia Forest Products, a leading manufacturer of decorative veneer and plywood in North Carolina. With more than 6 decades of experience, the company supplies nearly 1 billion square feet of veneer each year to the furniture and architectural industries. Unlike mills that focus on structural plywood, Columbia specializes in premium products, where the natural beauty of each wood grain is just as important as the material's strength and durability. As a result, every stage of the production process requires a careful blend of advanced technology and the skilled craftsmanship of experienced workers. The process begins at the veneer lathe, where logs are peeled into thin sheets just a few millimeters thick. However, producing veneer for high-end interior applications requires far more than machinery alone. Operators continuously monitor the peeling process, adjusting the rotation speed, cutting pressure, and knife vibration to ensure each veneer sheet remains uniform, free of tears, and preserves the natural beauty of the wood grain. The veneer sheets are then trimmed to standard sizes, joined together when necessary, and dried in carefully controlled kilns at moderate temperatures to preserve the wood's natural color and structure. Moisture content is also closely maintained at 6 to 8%, providing ideal conditions for the subsequent manufacturing processes. What sets Columbia apart is its Pure Bond adhesive technology, a testament to the company's commitment to sustainable innovation. At a time when the plywood industry relied on formaldehyde-based adhesives with harmful emissions, Columbia developed a soy-based adhesive by replicating the protein structure found in marine mussels. As a result, Columbia's products qualify for LEED Green Building certification, eliminate harmful emissions entirely, and provide a safer material for healthier living spaces. Pure Bond is more than a technical breakthrough. It is a commitment to protecting human health, replacing toxic chemical bonds with naturally derived proteins. During the pressing stage, the veneer layers are arranged with alternating grain directions to create a cross-laminated structure, giving the panel greater strength while minimizing warping and deformation. Pure Bond adhesive is then evenly applied in the optimal amount. The assembled panel is then transferred to a hydraulic hot press, where precisely controlled heat, pressure, and pressing time permanently bond the veneer layers into a single, durable panel. After leaving the press, each panel is precisely trimmed, sanded, and thoroughly inspected before moving on to the finishing stage. For premium furniture products, the surface is sanded using a multi-head sanding system to achieve an almost perfectly flat finish. Skilled craftsmen then carefully select veneer colors and match the wood grain, ensuring a seamless appearance when the panels are assembled into cabinets or wall cladding. Finally, the product is finished with either a UV coating or a matte base coat, depending on the design requirements. This not only creates a refined appearance, but also enhances moisture resistance, UV protection, and the long-term durability of the wood surface. But Columbia's true value extends beyond its advanced production line. Every piece of timber is sourced from FSC certified forests, ensuring that responsible resource use goes hand in hand with regeneration and sustainable forest management. As our journey through Columbia comes to an end, what leaves the deepest impression is not simply the power of technology. Machines can improve productivity, but it is respect for the raw material and dedication to the craft that create lasting value. That is also the message of this chapter, a place where modern technology and craftsmanship come together, so that every wood panel reflects not only technical excellence, but also the responsibility, integrity, and care of the people behind it. As we conclude this journey from the vast timberlands of the Pacific Northwest to some of North America's most advanced wood manufacturing facilities, what lingers is not only the immense scale of the production lines or the near-perfect precision of cutting-edge technology, but also the remarkable way science, engineering, and environmental responsibility come together to create an industry that is both highly efficient and truly sustainable. Each tree, after decades of growth, does not reach the end of its life when it is harvested. It begins a new journey, from logging, transportation, and raw material processing to veneer, peeling, drying, pressing, quality inspection, and finally becoming panels used in construction and furniture manufacturing. Every step is carefully engineered and rigorously controlled. Through Rayonier, RoyOMartin, and Columbia Forest Products, we can see that each company pursues its own unique strengths and manufacturing philosophy. Some stand out for their large-scale automated production lines. Others excel at maximizing raw material utilization. Some invest heavily in biomass energy systems, while others pioneer formaldehyde-free bio-based adhesives that are safer for both people and the environment. Although their approaches differ, they all share the same goal: producing higher quality products, using natural resources responsibly, and building a wood products industry that is designed to thrive for generations. Ultimately, this journey has done more than show us how veneer and plywood are made. It has revealed the true value of modern wood manufacturing. It is not merely a story of massive machinery or impressive production capacity. It is proof that when technology, quality, and respect for nature work hand in hand, every finished wood panel becomes the result of innovation, responsibility, and a long-term vision for sustainability, helping build stronger, more sustainable structures for today and for generations to come. Thank you for joining us until the end of this story. If you enjoyed videos like this, please like, share, and subscribe to the channel so you won't miss our upcoming stories. This is RaWMachines signing off. See you in the next video.